Find the partial fraction decomposition of 3 over x squared plus x minus 2. Now, the first thing I'm going to do is I'm going to factor the denominator. In this case, it factors into x plus 2 times x minus 1. I have two linear factors that I can now split up this fraction into x plus 2 plus x minus 1. And I have two different constants in the numerators because these two are linear factors. Next, I'm going to try to solve for a and b by multiplying both sides of the equation by this entire denominator on the left. So I end up with 3 on the left, and on the right, if I multiply the entire denominator by this fraction, the x plus 2 is going to cancel, but the x minus 1 is not. And over here, the x minus 1 is going to cancel, but the x plus 2 is not. Now I distribute the a and b to both of these fractions or expressions. So I have ax minus a plus bx plus 2b. And now what I'm going to do is I'm going to equate the coefficients by factoring out the x from the x term. So I have a plus b times x, and then the constants will be negative a plus 2b. And so you can see here that the a plus b must be equal to 0. This coefficient must be equal to 0 because on the left side of the equation there is no x term. So in other words, for the left side to be equal to the right side, a plus b has to be equal to 0. Also, for the left side to be equal to the right side, this constant 3 has to be equal to the constants, or the sum of the constants here. And so negative a plus 2b equals 3. So now I have these two equations. I'm going to solve it by substitution. I'm going to solve it by substitution. I'm going to solve for a in the first equation. A equals negative b. I'm going to plug that into the second equation here for a. And so I get b plus 2b equals 3. In other words, 3b equals 3 or b equals 1. And as for a, again, it's negative b, so a is negative 1. And so I'm going to plug those two values back into the original fraction here. So I have a is negative 1, so I have negative 1 over x plus 2, plus b is 1, so it's 1 over x minus 1. And so this is our final answer. But there actually is a shortcut method. Because there's only two constants, we can use the shortcut method. So what we're going to do is we're going to take this second line here, the 3 equals whatever. I'm going to copy that down. Alternate method. What you can do is you can plug in x equals to 1 for both of these, but x equals 1 so that it'll be 1 minus 1, 0. And so this entire term will cancel out. And here I get 1 plus 2, which is 3. In other words, 3b equals 3 on the left side. And so again, you can solve for b equals 1. And the similar idea, we can plug in x equals negative 2 on this side, so that this term will cancel out. On the left, I'll have negative 2 minus 1, that's negative 3, times a equals to 3. And so you can see a equals negative 1. So that's kind of a quicker, easier way to find the same two constants we found using equating coefficients and the system of equations.